So this is part 2 of section 1.9. I'm really not getting to anything new just yet, but there will be something new that's important after I flip this page. So I'm going to continue simplifying using the distributive property. I'm going to get rid of the parentheses. I'm going to leave the signs. And now I'm going to multiply the negative 3 by the 5y cubed. I'm going to multiply the negative 3 times the 6y, and I'm going to multiply the negative 3 times the 1. If you know how to simplify these, I'm doing way more work. I could get to the answer directly, and if you can get to the answer directly, eventually I'll get to that place when I get into the next chapter. But for now, I'm doing the things the proper way as opposed to the shortcut way. So first multiplication, I multiply the negative 3 and 5 and get negative 15. I leave the y cubed, leave the minus sign. Second multiplication, I multiply the negative 3 and 6 and get negative 18. Leave the y, two signs next to each other, I'll put it in a parentheses to separate the signs. Last multiplication, I multiply negative 3 times 1 and get negative 3, two signs next to each other. This is multiplied. Now I'm going to simplify even more. This double negative I'm going to make positive. And when I make the double negative positive, I don't need the parentheses anymore. And I don't generally like to see two signs written next to each other when they don't need to be. That last plus a negative is the same as a minus. Minus a positive is the same as plusing a negative. And if I was rewriting this, that's the way I would rewrite it. And if I was teaching being lazy, which I will in the next chapter, I would have taught you how to get from that to that without doing this formalized work. I just wanted to do the formalized work at the beginning because it's maybe important to know a little bit of theory. But if you're able to go from the problem to the answer because you know the shortcut, you're more than welcome to use the shortcut. 36, I'm going to leave the plus sign between. I'm going to multiply 2/3 times 6/9 x. And I'm going to multiply 2/3 times 15 over 8. This is going to need me to do some canceling. Between this 3 and this 6, I'm going to cancel by 3. I'll go 3 divided by 3 is 1. 6 divided by 3 is 2. I'm going to leave the x. I'm going to multiply the 2 and the 2 that are left over and have a 4. Multiply the 1 and the 9 down low and get a 4/9 x. After my plus sign, I'm going to cancel the 3 with the 15. 3 divided by 3 is 1. 15 divided by 3 is 5. I'm going to cancel the 8 with the 2. 2 divided by 2 is 1. 8 divided by 2 is 4. Then I'm going to multiply the 1 and the 5 and get a 5. I'm going to multiply the 1 and the 4 and get a 4. For an answer, should be writing equal signs because everything is equal to the line above it. The best answer for problem 36 is 4/9 x plus 5/4. If you wrote a slightly different answer, there are different ways to deal with the x. This is just the most natural way. If you wrote a slightly different answer and you want to know if it's correct, shoot me an email, show me your answer, and I'll tell you whether it's a good one or not. 38, I'm going to leave the minus sign between. I'm going to multiply 3/5 times 15 over 9x. And I'm going to multiply 3/5 times 7/6. Do some canceling. For the first 5 and 15, I'll divide them by 5. 5 divided by 5 is 1. 15 divided by 5 is 3. I'm going to cancel the 3 with the 9. 3 divided by 3 is 1. 9 divided by 3 is 3. And now I'm going to cancel this 3 with this 3. 3 divided by 3 is 1. 3 divided by 3 is 1. For my numbers, I'm going to multiply the 1s and the 1s. So up top, I get 1 times 1. Down bottom, I get 1 times 1, and here I have an x. That I probably could just write as 1x. And I'm not remembering if we've done this or not, but I believe we would know that that coefficient is implied. If not, that's extra that we'll cover next chapter as well. Next, I'm going to work on the next multiplication. I'm going to cancel the 3 and the 6 here. 3 divided by 3 is 1. 6 divided by 3 is 2. Now I'm going to go 1 times 7 is 7. 5 times 2 is 10. And this is going to give me 1x minus 7 tenths, which is just x minus 7 tenths. This whole section of the distributive property we're going to relive again in chapter 2. And this is almost a little bit premature and a bit much right now, but hopefully you can follow this. It'll make the next chapter easier if this makes sense. If not, let's get together and work on this. I don't think it's that hard, but I maybe didn't do all the theory that I'd want to do. The next group problems, there's just a few problems left. I need to lecture about fractions and divisions by 0. But before, this is going to help us understand when we have fractions that have 0 in either the numerator or the denominator. Fractions / division, fraction and division are kind of interchangeable with 0. In my standard example as I do this, this isn't have anything to do with a fraction that equals to 0. But most students, if I ask them what that equals to, they would tell me that's equal to 3. It turns out that anytime I reduce a fraction or I perform a division, which is equivalent to a fraction, I can check. It should be the case that if I work on this version to check, it should always be the case that the denominator times the answer has to equal the numerator. So I'm going to check to make sure that this is the case. Is the denominator 2 times the answer 3 equal to the numerator 6? And that's perfect. So I'm not going to worry about this because anytime I have a division, I can turn it into a fraction. Now, let's do a fraction with 0. Let me do a fraction with 0 in the numerator. Let me do 0 over 5, which is the same as 0 divided by 5. And let's say I don't know what the answer is, because I'm not sure. Even calculus students often don't know what the answer is. Well, I know what's supposed to happen. What needs to happen for my answer is it needs to be the case that the denominator times my answer has to equal the numerator, which is 0. So whatever the answer is, it has to satisfy this. 5 times the answer is 0. And the only way to multiply and get 0 is if one of the numbers is 0. So I claim that the answer has to be 0, because if I did my check, and I would say, is 5 times 0 equal to 0? And that would give me 0 equals to 0. It turns out that this isn't unique, that any fraction that has 0 in the numerator are equal to 0. Well, all fractions with 0 in the numerator without 0 in the denominator and not, this is a horrible grammar, 0 in the denominator. Equal to 0. And that means any division does as well. Let me pull out my calculator and just show you a bunch of fractions. Like, let me do the fraction 0 over 2. That's a fraction with 0 in the numerator. It equals to 0. The division form of that would be 0 divided by 2. And 0 divided by 2 is 0. If I did a fraction like 0 over 9, it's a fraction with 0 in the numerator. It's going to equal to 0. The division form of that is 0 divided by 9. So any fraction with a 0 in the numerator, any division with a 0 to the left of the division bar, they're all equal to 0. That's the easier case. The strange case is when I do this. What does 4 over 0 equals? Well, 4 over 0, I don't know what it equals. I'm going to say it equals some answer. And I know that this needs to happen. Whatever I put in for my answer has to be checkable. And to check, I should take the denominator times the answer, and that has to equal the numerator. For any fraction, when I write an answer to what it reduces to, it should be the case that the denominator times the answer equals the numerator. And I have major issues here because this side right here, it's always going to be 0. Because no matter what number I plug in for the answer, 0 times that number is going to be 0. There's no way, there's no number to plug in. There's no number to change the word answer to. To get the left side equal to 4. This, we say it has no solution. Fractions with 0 in the denominator are going to be undefined, or I guess better yet, I don't like that. We say undefined. I was thinking no solution because I'm thinking this example. But usually, a fraction with a 0 in the denominator, it's better to say undefined. Let me show you that. 4 divided by 0. My calculator gives me some sort of error message it doesn't understand. That would be another thing, a math error. It's just not possible. Undefined is probably where I want to go. So this fraction, 4 over 0, is the same as this division problem. Both of these are going to be undefined for an answer. And I could show you a bunch on my calculator. Like I could do the fraction 10 over 0. So they give me a math error, that's going to be undefined. Or the equivalent fraction division problem, 10 divided by 0, that's going to be undefined. If I did something like negative 17 over 0, fraction with a 0 in the denominator, undefined. Or negative 17 divided by 0, division problem with a 0 after the division bar, undefined. So as long as the numerator isn't 0, that's more complicated. That has to do with something called the indeterminate form, and I didn't really want to get into that. My calculator is still going to say it's undefined, but it's for a different region, more complicated than we need to be. So I'm going to say, just quickly, all fractions with 0 in the denominator and it really should not have 0 in the numerator. That's a special case that I don't really want to get into. We're going to call those undefined. And because any fraction can be turned into a division problem, any division problem with a 0 after the division sign is undefined, as long as I don't have a 0 preceding it. If I have a double 0, then that's kind of strange. So usually I just say 0 in the numerator or 0 before the division sign. I get 0. 0 in the denominator, or 0 after the division sign, I get undefined. That's important to know. So often, even students in a higher calculus class, they forget. And if they have a calculator, it will tell them which answer to put. But in general, students way high up in math don't do well with these. The last 8 problems are all just that, just knowing the difference between undefined and 0. Fractions with 0 in the denominator or 0 after the division sign are undefined. So 40 has a 0 in the denominator of a fraction. We're going to call it undefined. 42 has a 0 after a division sign. It's going to be undefined. And then fractions with a 0 in the numerator or 0 preceding the division sign in a division problem, those division problems and fractions are equal to 0. Doesn't come up a lot in our class, but it occasionally comes up. It comes up in the last chapter, and it might come up a couple times, knowing the difference between undefined and 0. It's an important skill. So this actually was an important section. And as I went through it, I felt like, maybe we're doing stuff that could have waited to the next section. So if I kind of overwhelmed you, let me know, and I'll try to say something better to unoverwhelm you. But for now, I'm just going to pause the video. You should be, getting done with this section and then putting your 100% focus into the practice test. I always make my tests just like the practice test. So if you can perfect the practice test, you're going to do great on the test.